So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 257 and in this video we continue talking about virtual function specifiers. So in my last video we talked about this explanation here. It gives us an introduction what virtual function specifiers are, but we have to dive into it a little bit more in detail to understand what's going on. And for this purpose I said you should try already to read this in detail part to try to understand it. Perhaps you can, perhaps not, no worry. And if you can, good. If not, now we are going to go through together and then I hope you will understand it. Alright, let's get started. So first of all, it says here, if some member function VF is declared as virtual in a class-based member function, for example, we have here a class base, we have here a function, it is a member function, and we have the word virtual, it is declared as virtual. That means this first part here, and some class derived. This one here is, we have here another struct, and it is inheriting from base, and it's, which means it is derived from this one, and here it is also declared the same function. We have here the same name. What happens then? Which is derived directly or indirectly. Directly or indirectly means here you can see the inheritance, how we inherit from the base. For example, you can see this derived struct here is inheriting how? Directly, because base is base. But what means then indirectly? Indirectly what means you have here another struct, and that would inherit from this derived, not from base, from derived, and this means then indirectly. For example, let me show you this one. Here we have here a struct A is our base, we have a struct B which is inheriting from A, and then we have a struct C which is inheriting from B in a virtual way, and you can see this struct C is inheriting, for example, this function here f indirectly from A. This means here this directly or indirectly. All right, and let's go on from base. So you can see from base. So again here this example we have f, and here is also f. That's very important. Even here is also an f, but that means indirectly. Has a declaration for member function with the same, and now there are some conditions how we can how they are if they are same or not. What it means is, let's go here to this one. We start here with a function, with a virtual function, and now we check if this function here and this function here are the same or not the same. What I mean is have this here properties. That's very important. They must be not the same. That's very important, and we will see this now. First of all, this name must be the same. Okay, f must be same. Second, parameter type list must be same, which means this little part here must be same. If there is, so you can see they are the same. There is no parameter. Here's no parameter, so this is considered to be the same. But important is this here. And this is that what we have not talked about till now, but not the return type. That is something new, and we have to talk about this. I will skip this, but keep in mind it has to do something with covariant. But let me give you an example. So, which means I can have, like I said, we have here the same function name, but I can have here not our return type void. Instead of void, I could have here something else, but this something else is specified as a covariant, and the covariant, we'll talk more in detail about this in another video, means it has to do with a derived class again. But keep in mind this can be changed, and that's very important to note, because many think this has to be the same as well in the function, in the derived function. No, that can look differently. That's very important here. Then we go here to CV. We know this shortcut. It says for const volatile. We know const is almost very important in many programming. You will see a const function, a const variable, and so on. But volatile we will see not so much. It's more a compiler instruction, but you will see it occasionally, so keep in mind that this one is okay. And here is again something what we have not talked so much, and it is also not so much used, are ref qualifiers in functions. So you see most time when they create function, it looks similar like this one, or there is sometimes this const, like I said, when we write here anywhere a const, right? We can make a const function or something. But what is a ref qualifier? We have not talked about this one. Let me go here to ChatGPT. I am too lazy to make all-time examples. That's why I said, hey ChatGPT, can you make me some examples? What I asked here was, let's see what we have here. Literal, derive base. Okay, here before we go to this const volatile, let me show you this one. This, but not the return type. So this this here again, back to this one, has where I said the return type must be not the same, right? Here is an example what ChatGPT created. So you can see it created here a base, it created here a derived, and here it created the same function name and the parameter list. You can see this here, the same, but here not the same return type. And this is the thing what we have to consider. This is this one, and it's not return type here. Let's go here. This one is called later covariant. I think they are talking here later about this one, or perhaps in another place, but here they talk also a little bit. And important is this one. So ChatGPT created for me something because I was too lazy. And then let's go to the next thing, this this one here, this const volatile. Like I said, this const we already know, right? It's all time a function. You can we see it almost all time volatile, almost randomly. Very rare that you see it as a beginner, but as a more advanced probably. Then this ref qualifier, we see it also very rarely. And what is that? And you can see here is a function, here is a and this is indicating a ref qualifier. We have not talked about this, but the difference is this one is just L value and this is just a R value call. So you have to call this with a L and R value. Let's see if they made here an example now. Where's the call example? Here. So you can see again the same thing. We have here an L value function. You have to call it with a L value, which means you create here. Let me make this a little bit bigger. So, oops. Sorry. So that you can see it a little bit better. So here you create a base object. This is this object here, this base. You make an object. Then you call it here with L value. This is a L value call, very important. And here is also L reference call, and that will call this function. They are exactly the same, only the difference is this here, this reference. And then this one is an R value call, and it looks, we have not talked in depth what this means. I just described it in shortly. L value means you need all time, the compiler need all time an specific address. So with other words, it knows exactly where he can save something, where he can get something. And the difference about R value was you create it randomly, which means you have not assigned anything specific. Let me make here a fast example about R value again. So when I create int random and then 5, you can see this one here will become an L value because we are creating a specific place. But when I assign this 5, you ask, hey, wait a minute, where does this 5 comes? And this 5 is created by the by the C++, and it is not a specific it has not a specific place where it is saved and where you as a programmer has access to it, and that's why it's considered to be R value. But perhaps we will go there again a little bit more in detail. It's not it's not that very important right now. So let's go back to our example. So you can see these two things are new. I would say this is new. We have not talked about this one. This one you know already, but this volatile is almost never used, and this ref qualifier is also not so much used because many don't care about how you call the functions, at least in a beginner level. Later probably you will have use cases, specific use cases, then you will call them. Alright, so you can see it's not so easy even at the start. Okay, let's read a little bit more. Also, so far we have just described how they should look like, right? So I talk more than it's very easy actually. My talk was longer than needed, I think, but let's go on. Then this function is in the class derived is also virtual, and this one is important now, which means all what I talked right now, if this properties, these requirements are fulfilled, which means here we have a fulfilled requirement like this one and this one, then this one here is also virtual, and that was what I explained in my last video. You have a start point, for example the base in this case here, it must start with the keyword virtual, but all other ones are optional. So that means here there is no keyword virtual, but this one is still considered virtual, and that is exactly saying this one here, this sentence here. Then this function in the class derived is also virtual. Okay, and now read this one here. Whether or not the keyword virtual is used in its declaration. Exactly that's what I said. Very important to note for later understanding. And let's go on. And overrides base virtual function, whether or not the word override is used in its declaration. Again, well, I talked also about this word override a little bit. This one here, it says is optional, which means this one you can omit, and still it is considered an override. Override means, you can see we have here a body, it says here base, then this one here, it says override, and later it will be used this body instead of this one. That indicates it's overriding. And this one is optional, which is bad for some reason. For beginners it's good that it's all time here. I mean, if it says here override, for a beginner and for readability it's very good, because you see a function, it's overriding, which means this is probably a virtual function, indicates that this is a virtual function, and you know, if you see this word override, there must be already a virtual function created, and so on. But the point is, because this one is optional, people and programmers can omit it, and you have still to know that this one is an overridden, probably a overridden virtual function. So if you see this word override, be happy, then you know exactly what it is. If not, you have to check sometimes, an additional more check. But the next point, what I want to point out is here, if you write override, for example, you have a function with the word override, then you have to provide a virtual function. So the other way is not possible. So the way from here, when you have a virtual function, you can omit override, and it is considered to be overridden. But if you provide override, then you need a virtual function here. We will make an example, and yeah, let's go on. But makes anyway sense, I think, but we will see. So I think let's see, should I go on or let's make a break? I think we make here a stop. So here, because we have to go now to this part, and then we have to dive into this one here. And the thing is, yeah, we make here a stop. All right, if you have any questions or any suggestions like all time, write in the comment section. And see you in the next video. Have fun. Bye. And like all time, never give up.